All right, hello everyone. Today we are taking on a new unit. This is an introduction to trigonometry. Sometimes we call it trig. So first, just what is trigonometry or trig? It's a branch of mathematics that studies triangles and the relationship between their sides and their angles. The word trigonometry is derived from the Greek words tri, which means three, gon, which is sides, and metron, which is measure. So what I'm giving you here is a visual just as a good starting point. So I've shown you that it's a right triangle. There's my right angle right there. And this angle right here, we think of it as our reference angle. That notation right there is the Greek letter theta. Let me write that. So it's like drawing a circle with a little horizontal segment in the middle, and that is theta. Okay, and again, it represents our reference angle. Okay, so here, again, my starting point is this right triangle. So we know that when we have similar triangles, we know that all of their corresponding angles are congruent and all of their corresponding sides are proportional. They have the same ratio. So if I take my original triangle like this, I can scale it up. So imagine that I add a segment right here, and I show that it's a right angle right here, then these would be parallel pathways. We would have a triangle here that is similar to the triangle here. Okay, so again, all those corresponding sides would have the same ratio. In fact, I could add a segment here and do the same thing, right? So if I add it like this, now I have a third triangle that is similar to those initial two, right? I'm just scaling the first one up and then even more. But I could also shrink it down. I could put a segment right in here, and I have another triangle that would be similar to all of the others. So what I've drawn in here are all similar right triangles. Okay, so again, all of the angles, the corresponding angles, they would match perfectly. They'd be congruent, but not the sides. The sides would be proportional. They'd have the same ratio. So this is what we build off of when we move into trigonometric ratios or trig ratios. We use SOH CAH TOA to help us remember the relationships. So the first one that we see is the sine ratio. So the sine ratio says that no matter what we have here, whatever this angle is, okay, it could be 10, it could be 20, it could be 30, it could be 80, right? It just has to be something that's more than 0 and less than 90 because we're dealing with a right angle. So whatever these two angles are, they have to sum to 90 degrees. So again, this angle has to be a little bit more than 0 or a little less than 90 or anything in between. But let's give it a concrete value for a moment. Imagine that it's 10 degrees. What ends up happening is that our sides, the ratios, are set in stone. So my sine ratio says if this is the reference angle, this would be the side that's opposite. This would be the hypotenuse. That ratio would be a constant. It would be always the same regardless of how big the triangle is, right? Because if I have an angle measure here that's set, say it's 10 again, for example, and this is 90, right? My triangles, I could scale up, I could shrink down, but they will be similar and our sides will have the same ratio. So the sine ratio, it says opposite to hypotenuse. Cosine says adjacent to hypotenuse. And tangent says opposite to adjacent. So all of those are ratios that are set in stone. So if this angle right here is my reference angle, this would be the side that is opposite, because it's directly across from that reference angle. This would be the side that's adjacent. It's always a leg. Your legs are always the perpendicular sides. So here is the adjacent side, or the adjacent leg. And then the hypotenuse is always the hypotenuse, right? So the hypotenuse is always opposite the right angle. It's always the longest side of any right triangle. So here is the hypotenuse. Okay, so if I move that reference angle, let's say that I put it right here instead, then in relation to this angle, theta, the reference angle, this would be the side that's opposite. This would be the side that's adjacent. Again, it's always a leg. It's one of those perpendicular sides. And then the longest side, always opposite the right angle, that is the hypotenuse. Okay, so again, we remember these ratios here by SOH CAH TOA. So the sine ratio says, okay, for whatever angle measure that's the reference angle, the opposite side over the hypotenuse, that ratio will be fixed. Okay, cosine is the adjacent over the hypotenuse. That ratio will always be fixed. Tangent, opposite over adjacent, right? That ratio will always be constant as well. So again, here is the SOH, here is the CAH, and here is the TOA. Okay, let me slide this up. So here what I've drawn on this sheet, I have three very different looking triangles. They're all right triangles, and I've marked a reference angle of 10, 45, and 80 degrees. And if I'm looking at sine, I know that sine theta, so sometimes we just abbreviate it as sin, that's what it looks like in the calculator. So sin theta, so the sine ratio for any specific degree measure will always be looking at the opposite side over the hypotenuse. So for our purposes, let me just shade that to really focus on those sides. So from this angle, my reference angle, this would be the side that's opposite. I'm shading it in red. Make sure you can see it all in view. And then I'm going to shade the hypotenuse as well, always opposite the right angle. Okay, and what I'm really interested in is, well, what's happening with the ratio as that angle measure is increasing? So here was looking at sine 10. What's the ratio of red to blue? Sine 45, what's the ratio of red to blue? Sine 80, what's the ratio of red to blue? And we should see that it's going to be increasing. As our angle measure increases, right, the ratio of that opposite side to the hypotenuse, it's getting closer to 1. Let me show you that using a trig table. So here is a trig table. Let me zoom out so you can see the whole thing. We have the same thing in our calculator. Here the trig table is giving us degrees, the nearest, rounded to the nearest degree. And it's giving the ratio to the nearest 10,000th position, so 4 decimal spots. So if I focus on sine, what it's showing me is the sine ratio for any angle measure. So look at the degree measure here. So as the degree measure increases, what is happening with the sine ratio? So as I trace it down, I see that it's getting bigger and bigger. Let me follow it over here, because here's a degree measure of 46, all the way down as it gets closer to 90, right? We can see that the sine ratio is getting closer to 1. So here, let me pull back away, look at my picture down here. Again, if I'm looking at sine 10, sine 45, sine 80, right? Again, I'm seeing that the ratio of that opposite side to hypotenuse, right, it's getting closer to 1 as that angle measure is getting bigger. Let me write that. All right, so as the angle measure increases, the ratio of the opposite side to the hypotenuse gets closer to 1. Okay, and if I look it up on that trig table, I could actually tell you that the sine ratio for an angle measure of 10 will be about 0.1736, right? That's the ratio of red to blue here. Sine 45 would be about 0.7071. That's the ratio of red to blue here. And then lastly, sine 80 would be about 0.9848. That's the ratio of the side here to the side here. So just to show you where I'm taking that from my trig table, so if I look at sine 10, so here's sine, degree 10, right? That is the ratio that I'm looking at. So that's the ratio of the opposite side over the hypotenuse when the degree measure, the reference angle, is 10. And if I go to 45, let's see. Well, let's see, I'll go to the 80 to show you that one because that one's right there. So sine 80 right there, if I go over right here, I see 0.9848 right in there. So I can see exactly what that ratio is. I can see, oh yes, it's getting closer to 1. So again, let me just pull back and remind you that as that angle measure increases, the ratio of opposite to hypotenuse, right, it's getting closer to 1. So if instead I'm looking at cosine, so cosine is adjacent, oh, zoomed out the wrong way. So cosine is adjacent to hypotenuse, so let me write that. So cosine theta is adjacent over the hypotenuse. We should be seeing the exact opposite thing. So from my reference angle right here of 10, this would be my adjacent side. I'm marking that in red. Same thing here and same thing here. And then hypotenuse, I'll keep that in blue here, here, and here. So here, as our angle measure increases, we should see that the ratio of red to blue, the adjacent side to the hypotenuse, right, starts off closer to 1 and then it decreases, right, it gets closer to 0. So in cosine, we're seeing that as that angle measure increases, ratio of adjacent to hypotenuse, right, it gets closer to 0. Let me write that down. All right, so again, as the angle measure increases, the ratio of adjacent to hypotenuse gets closer to 0. Okay, and then if I use my trig table, let's say that I look up the first one. So if I look at cosine 10, so here's cosine, I'm looking at 10. Right here I'm seeing 0.9848. So again, ratio of red to blue starts off fairly close to 1. Okay, that angle measure increases. Cosine 45 would be about 0.7071. It ends up being the same as the sine 45 because both of these angles would end up being 45 here and here. Okay, and then cosine 80 ends up being about 0.1736. All right, so again, as the angle measure increases, we see that the ratio of adjacent side to hypotenuse gets closer to 0. All right, next page. All right, so in example 3, I'm saying shade the adjacent side of each triangle. So remember that when we're talking about adjacent, right, it has to be one of the legs. It's not the hypotenuse. So it has to be one of those perpendicular segments. So when I'm looking at theta, when I'm looking at that reference angle right here, what is the adjacent side? What is the one that it's touching, that it's right next to, but not the hypotenuse? So hypotenuse, I'm just going to cover it up. It's out. It's not an option. So right here would be the adjacent side, right? The angle is touching it right here. It's right next to it. It's close to. That's what adjacent means. All right, if I look in B, here's my reference angle. Here's theta. Which side is it touching? That is a leg, not the hypotenuse, and that would be this one right here. So those sides would be adjacent, right? Adjacent sides have to be a leg, and it has to be right here. It has to be right where that angle is, one of the two sides that make up that angle where theta is, right? The other one would be the hypotenuse. The hypotenuse is always opposite the right angle. All right, now shade the opposite side of each triangle. So if this is theta, that's my reference angle. This is the side opposite. Also, it's still a leg, right? It's one of the two perpendicular sides. And then over here, if this is my reference angle, theta, this is the side that's opposite right there. All right, next, find each ratio. So here we're saying, okay, we know SOH CAH TOA. Let's write it up at the top. It helps to remind us of our relationships. SOH CAH TOA. So let's start with the two sine ones. So sine 28. So from right here where my finger is, I'm looking at what is the opposite side over the hypotenuse. So here's the 28. Here's the opposite over the hypotenuse. So G to I. Sine 62. So now I'm going over to this angle right here, and I'm looking at my opposite over hypotenuse. So opposite hypotenuse, P to I. Okay, next one I'm looking at is cosine. So if I'm looking at my cosine ratios right here, cosine 28. So that's the CA. The CA, so adjacent to hypotenuse. So from here, here's my adjacent side, and then here's my hypotenuse. Might even help just to always draw that arrow in across from the right angle. Just reminds you that that's always the hypotenuse. So from this angle 28, adjacent to hypotenuse would be P to I. And if I go to the 62 degree angle, my adjacent side here would be G, and my hypotenuse is I, G to I. So something interesting is happening here that I'm hopeful that you guys can see. So we can see that right here, these end up having the same ratio. So sine 28 and cosine 62 have the same ratio G to I, just as cosine 28 and sine 62, they have the same ratio also, P to I. So the reason that is if I pick here, let me go to the sine 28 for a second. So from 28, the opposite side, G to I, ends up being the same sides when I go over here to the 62 and say adjacent to hypotenuse. So what we're sharing in common here are that the angles in these two slots, they're complements, right? Together they add to 90, and we see the same thing right here, right? These gave us the same ratio. These gave us the same ratio also. Okay, so now tangent. So tangent 28. So right here, opposite over adjacent. So G to P. And then from 62, right, it's going to be the reciprocal, opposite over adjacent, P to G. Okay, and then again, what I really want you guys to remember is that we saw that sine 28, was the same as cosine 62, just as cosine 28 was the same as sine 62. Right, we saw that relationship up above. All right, let's do it one more time. But now instead of marking the angle measure, I'm just using letters. So I have angle A and angle B right in those two positions. All right, so looking at SOH CAH TOA, again, I'm just going to write that out at the top. Helps keep us all grounded in remembering our relationships. So sine A, so from this angle, right, again, I'm going to remind you that this will always be the hypotenuse opposite the right angle. So sine A would be opposite over hypotenuse, so y to z. Sine B, so from here, opposite over hypotenuse would be x to z. Cosine A, so from here, adjacent hypotenuse x to z. And then over here, cosine B, adjacent hypotenuse y to z. We're seeing the same thing play out. Right? These end up being the same, and so do these. We should recognize that sine A is the same as cosine B, and that cosine A is the same as sine B, because A and B are complements. Together they add to 90 degrees. So now how about tangent? Here is A. So opposite, adjacent, so y to x. And if I go tan B, so over here, opposite, adjacent, it's just the reciprocal, x to y. All right, one last skill, example 7, fill in each blank. There's no picture here, but if I say sine 15 is equal to cosine blank, I really just need the complement of 15, which is 75. So again, they end up being equivalent when they are complementary angles. And complementary angles have measures that add to 90 degrees. All right, so then looking over here, cosine 42 equals sine blank. I'm just looking for the complement of 42. And the complement of 42 would be 48. Okay, so cosine 42 will be equivalent to sine 48. All right, that's all I have for today. Have a good rest of your day, guys.